Hello, everyone. My name is Ori Kam. I'm a developer at Mellanox. I will be introducing the Hairpin offload today. Actually, we talked about a lot in these presentations about offloading, and this is one of them. So let's talk. First of all, we'll see what is the Hairpin feature, what is the motivation of using it. We'll see some test case. We'll see the DPDK API that required some changes, and what are the next steps regarding this feature. OK, first of all, it's named after a woman hairpin, which goes right through the air and comes right back out. Trust the bald guy to know. And second of all, we can look at it as a bump in the wire. The traffic flows, goes through the NIC, gets modified, and continues on the wire. If you notice, both in all cases, we don't use CPU utilization, and we don't. OK. Hairpin is the opposite direction to the loopback. If we see in the upper figure, we see a packet arriving from the wire, in this case, a test generator, received by the NIC, and then looped back to the packet generator. The CPU itself is unused. The other way around, in the lower figure, we see in the loopback case, the CPU sends the traffic, the traffic is received by the NIC and sent back to the CPU. In this case, the wire doesn't see any traffic. From DPDK perspective, we're actually creating two DPDK queues, one TX queue and one RX queue, which we are binding them together in NIC level. So every packet that is arriving through the RX will go right to the TX queue without going through the DPDK application. Another thing is, like I said, the Hairpin is part of the full offload offering, which we'll see in a minute. OK. Here we have a slide that describes, in basic terms, the two kinds of offload that we use when we're talking about RTE flows. We have the partial offload, the upper figure, where some traffic is being received by the NIC and sent back to the DPDK application, which also gets the data and also controls the NIC by inserting more flow rules. For example, the mark action, the RSS action, count, and any other. The lower figure shows the full offload case, where the DPDK application only inserts flows. And then, based on those flows, the NIC implies the action requires, decap, ncap, whatever, and then moves them directly to the VM in case of SRUV, for example, or back to the wire in case of Hairpin. Please note that we are losing some control or visibility when using full offload. We can add some counter, for example, in the RTE flow and then query to see if the flow is dead short or not. But basically, we are losing visibility of the flow of the traffic. Target application for such feature are, for example, gateway or load balancer. Both of those kinds of applications are receiving traffic, modifying the header files, and sending it back to the wire. OK. Here we'll start seeing an example. In this example, we're receiving a packet, then decapping it and capping it with a different header, and sending back the modified packet. This can be done in two ways. First of all, actually three ways, but I'm going to talk about two. There's the basic one that the application does everything. We have the partial offload, which is this left side, which means the packet is being received by the NIC. It marks the flow, and then transfer it to the DPDK application. The DPDK application, based on the mark action, decaps the packet and re-encap it, send it back to the NIC, and then back to the wire. On the Hairpin case, if you're using Hairpin case or any other full offload, what happens is the packet is being received by the NIC, it's decapped by the NIC, encapped again by the NIC, and sent back to the wire. Again, the DPDK application doesn't see any of this traffic. Here's some setup information that I used. This slide is less interesting, but since there is some numbers, so it's important to show it. In this slide, it's the setup configuration. It's more interesting because here we can see how we created the mark flows using RT flow, what is the hairpin flows that we generated, how we run the test PMD command for both the hairpin and the mark and the partial offload. Okay, this is the most important slide, basically. In the back bars, we can see the compression between the max PPS that we got when we're using partial offload or hairpin offload. As we can see in both cases, we're getting around 25 million packets per second. The interesting stuff happens on the front two bars, where we see what the number of cores we need in order to achieve the number of PPS. So when we're using partial offload, we see that we need to use 8 cores in order to achieve the maximum PPS. While when we're using hairpin, we actually don't use any cores, so it's 0. So the main advantage from this point of view, the application gets the maximum PPS without wasting any cores. As I know, everybody knows how important that is. Another thing, this decap and encap is a relatively simple case because the software is quite easy to decap something in software, just move pointers. But if there are other actions that need to be done, NAT or anything else, it will take even more cores and will achieve less PPS in the case of partial offload. From DPDK API changes, now there are 2 kinds of queues. We have the hairpin, we have the standard queue, and we have the hairpin. In order to configure the RX hairpin, we need to bind it to a TX queue, 1 or more, and in order to configure the TX queue, we need to bind it to RX queue. We don't require any memory pool to be allocated by the software because it's only internal inside the NIC itself. We cannot use the hairpin queue in the data path. For example, we cannot say, we have hairpin queue, we can use the burst function, for example. It will not going to work. It also will not work all the statistics that we are currently getting on a port because, like I said, it's transparent to the DPDK application. The last things, in order for us to use it, we must use the RT flow with queue or RSS action. In order to achieve this and to test it, we added a new parameter, command line parameter to the test PMD, hairpin queue, which this parameter creates additional NRX queue and NTX queue to be used as hairpin queues. The first hairpin queue that will be created will be binded to the first TX queue. The second second RX queue will be bounded to the second TX queue. Again, this is in test PMD. In real life, you can do whatever you want. Here we'll see, for example, an example. We created 3 RX queues, 3 standard RX queues, 2 TX queues, and 2 hairpin queues. Again, those numbers can be any numbers. You can technically create a test PMD without any standard queues and only hairpin queues. It's also valid. As we can see, when using this command, we are getting 5 RX queues that the last 2 of them are hairpin, and we're getting 4 TX queues that the last 2 of them are hairpin. And then we're binding between the first RX queue, which is hairpin index 3, to the TX queue index 2, and RX index 4 to TX index 3. So any packet that will be received by RX queue index 3 will be automatically moved to TX number 2. Okay, and the final step is in order to run it, we create RTE flow command. In this command, we are matching on IP, on some IP destination. We decap the packet and send it to queue index 4, which is hairpin queue. The other itself, the NIC, will transport it back to the wire using the relevant TX queue. Okay. What are the next steps? The next steps are, first of all, quality of service. Queues will be able to have priorities, and based on the routing, we can set that high priority traffic will go to a specific queue, and then it will get more bandwidth or less bandwidth, according to the traffic. Another thing that we want to support is cross-port hairpin. Currently, we support hairpin only in the specific port. Futurely, we want to support hairpin between 2 different DPDK ports and 2 different NICs even. Currently, Mellanox supports it from hardware point of view, but in DPDK, it's much more harder. It's harder to implement this feature. Thank you. It was a very short talk. I spoke very fast, I think. Question?
How do you synchronize between the regular queue and a hairpin queue for a flow which is dynamic?
Sorry, I didn't hear the question.
How do you synchronize between the regular queue and the hairpin queue when the flow is dynamic?
I'm not sure I understand what the flow is dynamic. When you insert a flow, you insert a flow. It's a flow.
So let's say I am creating a flow on demand for a SYN. You could have out-of-order packets. So how do you synchronize between a regular queue and a hairpin queue?
I'm not sure I'm understanding your question, but basically it's not synchronized because like now you have 2 queues, you can insert 2 flows and say this kind of traffic will go to one queue and the second kind of traffic will go to the second queue. It's synchronized in hardware level. You don't need to synchronize it. Everything is transparent. So I'm not sure what you're about the synchronization question.
Okay.
Sorry. Basically, it doesn't need any synchronization.
I have a question for that. Why you introduce the queue concept in this API? Because this is port-to-port traffic, right? So in the port respective, there is no queue concept. So what is the purpose for that queue? Multiple queue or just one queue, or what is the purpose here?
Okay, if I understand the question correctly, basically, it's queue property. It's not port property. Like I said in this slide. Wait, we'll get to this. In this slide, the port itself can have a number of queues. For example, it will have one Rx queue in order for the application to receive the first packets of a type. And then after the application receives the packet, it will say, oh, this packet, for example, is very suitable for Hairpin flow. And then it will insert an Hairpin flow, which says this kind of traffic will go to queue number 3, which is Hairpin queue. And then the application will be unaware of any more of this packet. But basically, it's a queue property. It's not a port. The port can support as many queues, as many Hairpin queues as we want, and as many Rx queues as we want.
Okay, thank you. So have you measured the impact of the maybe the traffic to the host and to host the CPU and the traffic go to maybe another port? So is there any maybe bandwidth impact if the traffic for Hairpin is much more than the traffic go to the CPU? Is there any impact? Yeah.
Are you talking between different NICs or in the same NIC?
In the same NIC, because it's just one PCIe interface, right?
Basically, it doesn't even go. It doesn't necessarily need to go through the PCI itself, because it depends on the NIC architecture and everything. But the NICs itself, inside the NICs itself, there is the queues. So it might need to go depending on the architecture of the NIC. If you use host memory, maybe it needs to traffic through the host memory and using the RT. But it still saves the CPU. And in any case, if you think about it, what the application will do in normal case, one second, let's find the slide. Here, in normal case, the packet will be arrived to the NIC, will go through the PCI, then to the CPU, and back, PCI, NIC. So in any case, even if the memory itself is in the host and I'm using PCI bandwidth, I'm still saving the CPU.
Okay, okay.
Because in any case, the PCI will be the same. So it doesn't matter. So does that answer the question?
Yeah, partially. Then we can talk offline. Thank you, thank you.
Sure, no problem.
Hi, thanks for your talk. I have a problem about the usage. In a up-layer app, for example, VPP, if VPP want to leverage this feature, it has to know the very low layer topology. For example, how many queues do you have, and how many higher pin queues do you have, and if this TSQ and that RxQ belongs to the same port, right? I think it is not very easy to use in the up layer app. What do you think?
If I understand your question correctly, again, I'm not familiar with the VPP application, but basically, when the DPK creates a port, it then creates the queues.
Yeah.
Yes, the dev configure queue setup, RxQ setup and TXQ setup function. So the application knows, in any case, which queues are Hairpin and which queues are not Hairpin, because he configured them accordingly. So basically, when he knows it, he can know which traffic he wants to send.
Yeah. Maybe the DPTK plugin knows the very low layer topology, right? But the other graph node, for example, IPv4 forwarding node or the VXLAN node, they don't know the low layer topology. So how can they create the RT flow to leverage the Hairpin?
In VPP, if I understand correctly, I'm not sure of VPP, I think, but basically, when the application will receive, first of all, it will receive the packet in a slow path, which means it will not go through any offloads. It will be just like in OVS. The packet will be analyzed, and we'll say it's suitable for Hairpin or it's not suitable for Hairpin in some kind of logic. For example, the software said, it's IPv4, and it should belong to network XYZ. So it's good for Hairpin. Then it will insert the flow using RTE flows. And then the VPP will not see anymore this traffic, this packet, because it will be the responsible of, even in VPP, after you analyze the packet header, you need to do something with it. So one of the things to do is to say, OK, I'm downloading a flow rule that says, OK, these packets should have those actions, and write it back to the wire. Is that being clear? I'm not sure.
OK, thanks.
Again, we can take off offline.
Does this feature depends on the specific NIC?
It's implemented. It depends if the NIC supports it or yes or no. Yes. Like anything in the RTE flow, it's very generic. You need to give the action, the items, and validate it. Based on the validation, you know if the hardware can support it or not. For example, if there is some combination that might not be valid. For example, some hardware can do decap, but they cannot do encap, just for example, or anything else. So you need to validate the flow that you're going to try. And based on the hardware, it will return if it's successful. If it was validated, then you can use it or not.
And another question is, how can application to know the statistics of how many packets were used the Hairpin?
OK, good question. Like I said, in the RT flow command, there is also an action that said count, which means it's attach a counter to the specific flow, and then the application can query this counter. So basically, after you inserted this flow with the count action, the application can query whenever it wants, once a second, whatever, the counter, and said, give me how many bytes or packets move through this flow. Based on that data, it can age out the flow, it can insert a new one.
OK, thank you.
Sure, no problem.
I want to relate to the issue you asked about if the NIC supports this functionality or not. I agree this also relates to the notion you asked this morning about how the application knows what is implemented in the NIC or not. So doing it flow by flow is not really useful. It's more useful to this is a call for action maybe, to extend the capabilities so that you can ask the NIC instead of flow by flow, does it have the capability to do hairpinning? So we need to somehow build some communication channel between the smart NIC and the application on RTE Flow. Right now, we don't have a list of capabilities. So this is, of course, another one of the capabilities that should be supported. So that's one thing.
I would like to address this.
Sure.
It's exactly, we are discussing this in the mailing list with Andrew and a few other guys. This is from the beginning, the RTE Flow in general doesn't want to have capabilities. The reason there is no capabilities on RTE Flow at all is the reason that the possible metrics is impossible. For example, you can say, I'm supporting NCAP only if it's IPv4 tunnel. If it's IPv6, I cannot support NCAP. So how do I represent it in this capability? How can I represent in capability that I support mark action, but I cannot support mark and Hairpin in the same flow? So this is why from the original part, it was decided the only way to validate a RTE flow is to use validate. Capabilities are, I heard it from Thomas actually, it's a weak capabilities. I don't know from you, because even if you say we support mark action, it's not necessarily we support it in all cases, in all flows. So we need to think about a better way. Capabilities are not the way. But yes, there is already discussion starting to know how we can maybe improve the improve the validation to give the user a better understanding if he can do something or not. Capabilities are probably not the correct way, but again, it's under discussion also, and it's a very interesting discussion, so feel free to join in this. Look for mark action, something. It was a very hot topic in the last few days.
So I'm not saying this should replace the validation. Validation should, of course, happen because whatever configuration you do, you have to validate and see if the hardware supports it. Maybe it doesn't. But for example, general capability of hairpinning might not be supported. Yes, so there should be some discussions. That's just one thing. The second thing somebody asked about the counters. Counters, of course, important. So there is a way to get the information of the flow, right? Each flow you do have the information. So the flow capabilities, the flow counters will be updated using the hairpinning. But what's missing, what you said, is the important stuff is also to merge the ports. So this is a little bit trickier to somehow the port counts in the driver and the NIC are not updated when you're doing hairpinning. So this is a little bit more complicated. But also, someone asked about the application. So, for the application perspective, it's quite simple. For example, you do as in the example, you say, this flow should go just output port instead of going to the physical function or virtual function. Just go to another port. So, from the application perspective, it's quite simple and useful. And we're familiar with a lot of applications that are using this. So, this is not very complicated. It's true that we might know a specific queue, but if you don't need a lot of queues, you just notify this queue is for hairpinning, and that's simple.
Hi, I had a question. This is for the handoff between the slow path and the fast path, which is transferring from a regular queue to a hairpin queue. If there is an ongoing flow, which is a big flow, I would say, and you suddenly want to install a dynamic flow for that flow to take the hairpin, how do you transfer the packets from the regular queue to hairpin queue in order to make sure there's no out of order transfer? And basically, when you're dealing with an ongoing flow and you're doing this offloading, do you deal with those problems? Have you tested that?
Okay, I'll answer this. This is true not only for Hairpin, what you're asking, it's also true for OVS cases and any SRUV cases. As far as I know, I'm less familiar with OVS, for example, but the basic concept is the CPU gets the packets, it then prepares the flow, but it doesn't download it yet to the software, to the NIC. It sends the packets in the normal queues, and then downloads the flow. So basically, all the new packets will be received, but of course there is some critical point where you say, maybe the packet will be received by the software, maybe the packet will be received by the hardware. This cannot be avoidable, but basically if it's received by the software will forward it, it will see that there is already a flow matching it, so it will not try to download a new flow, and it will send it to the wire. itself.
But there's still some packets which will be intermittent.
In the middle, I think there was, again, there is some kind of, there is some kind of mechanism. I'm less familiar with how they implement it, but basically they're keeping the packets and sending them, and then only then downloading the flow rule. This is as far as I know.
Okay.
So I got more. So creation of a specific queue type seems nothing to do with RT flow, right?
No, yes.
So, and why didn't you consider, say, for example, ability to put RT flow to be able to in-queue into transmit queues in addition to RX queues, which would make it generic that you could just, whatever you match, you can in-queue to a TX queue, which goes out.
Just to make sure that I understand your
So
question.
normally, the things you queue with RT flow queue actions are queues that somebody in the system, dequeues from, right?
Yes.
So if you add the ability to in-queue into a TX queue, which would make it generic, you're just transmitting things out through RT flow instead of just creating one special queue type.
There was a lot of discussion regarding this, if I understand your question correctly. The reason is that, for example, like I said, Hairpin queue doesn't need mempool. It doesn't, the configuration is different. I need to bind it. So it was either they say, okay, take the standard TX and RX and add some variables to them, break ABI, and especially since it's a new feature, I'm not sure how it will evolve in the future, and use them. Second approach was the one that we took that says, okay, we have it's different parameters, it's different kind of queue. For example, Hairpin queue can support a lot of the offloads that normal queue can support. It's not used for this because it's already in the device and it's not, it can do our CRC, for example, or something. Some can, some make sense, some doesn't make sense. LRO packets, again, it doesn't make sense, these offloads. So either we mix those two functions together and get a lot of junk parameters, or we split them. So the idea was to split them, which looks better from software design architecture, at least from the point of view that I'm receiving it and the design.
One thing I've found with DPDK is it's quite hard to actually diagnose when there's issues with packets that are corrupted by some actions and things. Seems that going via hairpinning, we're now going to have even more of a diagnosability issue because the CPU doesn't get the packet that the NIC has rewritten. Have you thought about that aspect at all?
Do you think that, just to make sure that I understand your question, do you see the problem that the CPU doesn't get visibility of the packets? Am I correct?
It's mainly, like, we can't run TCP dump easily on this without, presumably the solution would be doing some mirroring to another port and seeing what the output packet is. But have you done any more thought on how you would diagnose issues where, like, actions are wrong?
I will answer basically, if I understand your question correctly. It goes to two things. First of all, the idea, for example, if I take SRUV, the idea is that you don't want to pass through the DPDK, otherwise you will waste a lot of time, a lot of CPU. And as a CPU, it's also costly to do all the interrupts. So it's not meaningless, but there is a problem. So, but there is a problem that you're losing the visibility, I agree. Some solution can be, as Shachaf, I think, said in his presentation yesterday, we can say some of the packets, send them back for inspection. For example, so you'll know that for like 10% of the packets are received by the core by the DPDK application in order to validate that everything works correctly. We have, like I said, also the count action. The count action allows you to say, do this flow is still alive or not? So there are some kinds of visibility. Maybe we should add more, but the basic concept is that you don't want it. You want the packet to go straight to the target. So
yeah, this is more for like when you're developing this, what's the way that I would diagnose whether the rewrite was actually working? And I think the answer is probably you need to hook up something at the other end and view the packet.
I'm sorry, I didn't hear, sorry.
So if I'm assuming that the code is not perfect on a NIC and that the programming is not perfect, I need some way to actually capture the packet in order to diagnose whether there's an issue. And when you have hairpinning, that becomes harder.
Okay, so in this case, the assumption is the other way around. The assumption is that the NIC is perfect. I know nothing is perfect in the world, but yeah, but basically, the more problematic is that you don't know if the flow is still alive or not, because the assumption is that if you press a flow inside the NIC or anywhere, also in software, it's the same. Software is more probable to issues that if you have some kind of logic inside the NIC, it will work. If it doesn't work, we have serious issues, which are much harder.
I've had plenty of hardware issues that I've needed to report, and yeah.
Yeah. Do you support a mirror? The question is simply, was the operation correct, right? If you're building something like this, I would want to know the same thing, right? I set up the capability, you fire the packet back out. What do? Be great to monitor it on the same box, right? So if you have the ability to port mirror what you've written out, that'll be kind of handy. So do you support something like that?
Currently, no, but I'm not sure. We are working on such features, at least on SRUV cases, and it will also work on this. I'm not familiar with the status of it. I think you could talk to Shahaf later. He's sitting over there. Maybe he can respond even now to this question. So we are working on it, but I'm not sure the status.
Yeah, so mirroring is a feature that we actually work on. And this is exactly to address the debuggability and visibility issues. It's not only for Hairpin, it's for any flow that you offload. If you direct it to a VF, or you loop it back to the wire. Okay, so looking on mirroring, we will not want to mirror every packet both to the target location and also to the host. So we are speaking on statistical sampling. Once every X packet, so in such percentage of the packet, sample it to the application along with the other action. And this can provide debuggability and logging on the application, specifically needed for firewalls or any kind of VNF that do these kind of actions.
Yeah. These two queues are attached to the same NIC, right, or same port?
Currently, yes. Currently, from DPDK concept, it's the same port and the same NIC and physical, also same physical and same DPDK port currently.
Right. So I think this feature could have been made more generic. Like requirement could be forwarding the autonomous forwarding packet from say one of the PCI interface to a USB interface, and the hardware could have simply, if you had provided the capability to create a RX queue and a TX queue without MBUF, right? And just provide a API to connect the two queues. It would have served the hairpin, as well as it would have provided a better solution for autonomous forwarding, wherein I can simply forward the packet from, say, one Ethernet interface to another without going to the software.
Like I said, one of the things that we are working on, and we want, and I'm not sure what is there, it's from DPDK perspective at least, we want to have the cross-port. But again, since we are talking about hardware level, it cannot, I don't think it can be between like Mellanox NIC and Intel NICs, or from Mellanox NIC to some software, because the NIC doesn't know how to do it yet. Maybe in future generation of NICs and everything, they will be able to have some API to talk between themselves. Currently, what is supported is between the same port. Hopefully, we'll get it to the point that we can support it between different physical ports. For example, one NIC and the second NIC, and route between them. I agree that the best way if we could support between any cases, but I don't think how it's possible.
Any last questions before lunch? Well,
Thank you.
given the amount of questions, you can see the audience was very interested and enjoyed, so please give a round of applause for